Since the dawn of humanity, the moon has been an object of mystery. We mark time with its phases. We try to interpret its features. And we wondered if life dwelled on its surface. In the mid-20th century, a golden age of science and technology helped us understand more about the Earth and its place in the cosmos. Yet the moon remained a puzzle. We'd only dreamed about flying in outer space, let alone reaching the moon. On October 4th, 1957, all of that changed.
Today, a new moon is in the sky, a 23-inch metal sphere placed in orbit by a Russian rocket.
I saw it. It was very bright, easy to see. And everybody looked up and thought, my God, the Russians are up there.
Sputnik was the first artificial satellite to orbit the Earth. It was launched in the midst of the Cold War between the United States and Soviet Union. Americans were stunned that their country had fallen behind in the struggle for space supremacy.
The radio was on and said the Russians have launched a satellite. And I was crushed. I mean, I couldn't believe it.
It was very much a space race at that time, and of course was for decades after.
You are hearing the actual signals transmitted by the Earth-circling satellite, one of the great scientific feats of the age.
I believe that this nation should commit itself to achieving the goal before this decade is out of landing a man on the moon and returning him safely to the Earth.
The Kennedy announcement was taken very seriously and with a great deal of excitement, but also with a lot of skepticism. It hadn't been done, and no one really knew if you could even do it.
At the time, the majority of the rockets we had tried to launch and the majority of the rockets the Soviets tried to launch blew up.
President Kennedy's goal would demand a colossal effort from newly formed NASA, the National Aeronautics and Space Administration. While engineers were busy building rockets, scientists had a multitude of questions about what we would find if we made it to the moon. Planetary scientist Robert Strom remembers his reaction.
I was floored, basically, because we knew very little about the moon, and we did not know what the composition of the moon was. We didn't know the physical state of the surface, whether you would sink into dust or whether it was rock.
There was a faction in planetary science that thought that the dust would be so thick that any astronaut trying to land on the moon would be buried or sink out of sight.
The questions were vast. Many of the answers would come from the University of Arizona, where one of the world's first research institutions dedicated to the solar system was taking shape. The path to winning the space race would wind through Tucson, Arizona. Long before the space race got underway, one scientist was already trying to unlock the secrets of the moon. His name was Gerard Kuiper.
I suppose what you'd like now is the chemistry. If you could get a man up there to do a chemical analysis, I suppose that would advance your knowledge immensely.
Well, we would very much like to know in detail what the surface of the moon is composed of, and to send a man up there, that is just out of the question at the moment.
Kuiper was born in Holland in 1905. He grew up in a humble family that tried to cultivate the would-be astronomer's interests. Kuiper's daughter, Sylvia de Tom, explains.
Rather soon in his life, at his school, they realized he was a rather intelligent person. He used to like to make maps, and he was very interested in the stars. I think an early present from his parents was a small telescope.
In 1924, Kuiper entered Holland's Leiden University, a renowned astronomy school. Because of his modest upbringing, he often felt like an outsider.
In order not to be laughed at, he had to train himself to speak, proper Dutch. There were, I think, the equivalent of our fraternities and sororities, but I think he and some friends had something called the Rotte Pere Club, so the Rotten Pear Club.
Kuiper wanted to study how our solar system had formed, but his interests were out of step with astronomers of the time. The same year Kuiper enrolled at Leiden, astronomer Edwin Hubble discovered the universe extended far beyond the Milky Way galaxy. Most astronomers were only interested in looking beyond our solar system. Exploring the moon and planets was a dream relegated to science fiction. In 1936, Kuiper became a staff astronomer at the University of Chicago's Yerkes Observatory, located 2 hours north of Chicago in southern Wisconsin. Founded in 1892, Yerkes was considered a world leader in modern astrophysics. Kuiper became the director in 1947. He discovered new moons around Uranus and Neptune, and an atmosphere around Saturn's moon Titan. In the mid-1950s, Kuiper turned his attention to Earth's moon.
He was in charge of the International Astronomical Union committee that was planning how to study the moon and planets. And so as part of that, he looked at the quality of existing maps of the moon, and he realized they were lousy. The previous map of the moon was published in 1935. It was hand-drawn. So Kuiper's idea was to collect the best photos of the moon that existed and make a photographic lunar atlas. So it would not be somebody's interpretation of what craters looked like, but what the actual photograph showed.
Kuiper took his ideas about the moon to a 1955 International Astronomical Union conference in Dublin, Ireland. There, he had a fateful encounter with Ewan Whittaker, the director of the lunar section of the British Astronomical Association.
I thought, oh, Gerard Kuiper, I know that name. He's discovered the satellites of Uranus, Neptune, and a lot of other good work.
At one of the conference meetings, Kuiper distributed memos seeking input on his ideas for a photographic lunar atlas.
So I took these papers and put them in my satchel thing and didn't think much more about it until I got home, and I thought, I'll write a letter to Kuiper. This is about 3 months later. He answered the letter, and afterwards I found out that that was the only letter he did receive. Just that one. Nobody was interested in the moon.
Kuiper invited Whittaker to Yerkes for a 1-month assignment to work on the lunar atlas. In a stunning coincidence, Whittaker left for America on October 5, 1957, the day after the Soviet Union launched Sputnik.
I got to the airport and I had some time to spare, kicking my heels around, and there was a newspaper stand there. The big headlines: Russia orbiting a spacecraft going around once in 90 minutes. I thought, I'll pick this up and look at the paper. Kuiper might be interested in this.
Neither Kuiper nor Whittaker could guess how much the space race Sputnik triggered would change the course of their lives. Shortly thereafter, Kuiper secured funding from the U.S. Air Force to complete the lunar atlas.
At that time, the Air Force was interested in the moon as a potential military outpost, a military base, something of military significance and value.
With the new funds, Kuiper offered Whittaker a full-time job at Yerkes Observatory, and Whittaker moved to America to work on the lunar atlas in 1958.
Well, we have the surface pretty well covered with photographs, with different illuminations at that, and just now we are in the process of copying these up for the prints which will be used in a photographic lunar atlas.
At Yerkes, Kuiper was collecting the best photographs of the moon taken by observatories around the world. New faces were brought in to help with the project. Alan Binder, an undergraduate at Northern Illinois University, remembers his first encounter with Kuiper in 1958.
I drove up to Yerkes and met Kuiper, and I had the book that has all the courses in that you can take, and I had marked my grades, against that. And he said, "Well, what are those letters?" And I said, "Well, those are my grades in math and physics." And he said, "Do you have a summer job?" And I said, "Not yet. I just got home from college. Would you like to work here?" And I said, "Of course I'd like to work here."
My job assignment was to work in the darkrooms. They learned quickly that I'd done a lot of darkroom work as an amateur photographer at home, so I fit right into that operation. I found myself within a week, or at most 2, standing side beside him in the darkroom with these large 16 by 20 trays of developer. Here I was an undergraduate summer helper, and he was the director of the observatory.
He didn't stand, we found out later, on whether you got PhDs or what. He depended more on your interests and what you could do practically.
Not everyone at Yerkes approved of Kuiper's hiring of staffers and students without many academic credentials. Additionally, his personality brought him into conflict with many of the observatory's long-term employees.
Kuiper was disliked by the other professional staff. Partly, Kuiper's a very arrogant person, very condescending, and he could rub you the wrong way very easily.
He could be extremely abrasive, and he could, with some withering criticism, just reduce you to a little pile of insignificance. But at the other times, he was enormously gracious. friendly. He didn't joke much at all. He was always Dr. Kuiper. He certainly wasn't Gerard.
I like Kuiper. I had the greatest respect for him. I never ever spoke to him unless it was Dr. Kuiper. Even today, if he were alive, and I'm an old man, I could not go up and say Gerard to him. I would say Dr. Kuiper because I have that much respect for him.
As Kuiper focused on the lunar atlas, he clashed with Yerkes astronomers that were not interested in studying the solar system. Additionally, the southern Wisconsin skies were often cloudy, hindering observations. A new national observatory was being constructed on Kitt Peak, about an hour from Tucson, Arizona. The Southwest offered cloudless skies, tall mountain ranges, and dry air, which made for more observing time and sharper views of the cosmos. The Santa Catalina Mountains above Tucson were a ripe location for new observatories. Kuiper met with officials at the University of Arizona about the prospect of relocating to the desert. The university was eager to work with an astronomer of Kuiper's stature.
Kuiper had a way of smelling out the right thing at the right time.
In March of 1960, he came to us, we had a little meeting one day. He said, "Well, folks, we're moving down to Tucson, Arizona."
He used to tell me 325 days a year of sunlight here. And
This was where the action was anyway. It looked like Kuiper was on a fast track to whatever future there was in planetary science.
We knew what Tucson and surroundings was like, and we thought, a little different from both England with its green and Williams Bay with its green. Anyway, we thought, okay, lead us along.
In 1960, with Kuiper's group preparing for the move to Tucson, the photographic lunar atlas was finally published. Its loose-leaf sheets came in a large red box that sold for $30. It was the most comprehensive photographic record of another planetary body ever published. Charles Wood was an undergraduate astronomy student at the University of Arizona in 1960. He took notice of the new group on campus.
I saw in the local newspaper a picture of Kuiper and Barbara Middlehurst and Ewan Whitaker and Di Arthur moving boxes out of a van that they were unloading, and it said Dr. Gerard Kuiper, who I'd never heard of, and his staff have just moved here from Yerkes Observatory, which I hadn't known of, and they're here to set up a Lunar and Planetary Lab, and I thought, that's exactly what I'm interested in.
The Lunar and Planetary Lab was initially housed in the University of Arizona's Physics, Mathematics, and Meteorology building, as well as temporary Quonset huts left over from World War II. In 1960, just a year before John F. Kennedy declared Americans would land on the moon, NASA asked the Air Force for a version of the lunar atlas with a coordinate grid. It would be used to scout for potential astronaut landing sites.
Delegation of 3 or 4 from ACIC came out and said, "Hey, NASA wants us to map the moon. Can you help us at all?" So we said, "Oh, ho, ho."
For Kuiper's third atlas, the Lunar Lab set out to show how each section of the near side of the moon appears from directly overhead. Because the same side of the moon always faces the Earth, astronomers were previously unable to get a clear look at the features near the sides. William Hartman explains the creative methods that led to the 1963 rectified lunar atlas.
Here I am, I'm the moon, so I keep the same side toward you if you're on the Earth, which means that you can only see funny details of my ear, but it's a little hard to tell what that really is. Kuiper had collected the very best photographs of the moon on these glass plates. We projected those down a hole onto a white globe that was about 3 feet across. Kuiper had me photographing that globe, and we could see features that normally people can't see from the Earth clearly.
As the race to land humans on the moon continued, NASA took notice of the Lunar and Planetary Lab's pioneering techniques. In 1964, Kuiper secured NASA funding for a multi-story space sciences building to house the lab. The space agency also funded the construction of a 61-inch telescope in the Santa Catalina Mountains. It was used to create the 1967 Consolidated Lunar Atlas, one of the most detailed telescopic surveys of the moon ever done. Steve Larson was an atlas co-author.
There are only 250 of these made, but they represent the best images of the moon that we had at the time. So here's Clavius, which has other craters inside. And you can look and see on the limb mountains that are sticking up. What we did then was to enlarge these onto a large film that had been dodged to make the terminator, the normally dark terminator area, lighter and the bright area darker so that they print nicely.
With data for the atlases pouring in, Kuiper's students scrambled to interpret what they were seeing. It was clear that in order to understand the moon, the Lunar and Planetary Laboratory would have to broaden its scientific expertise beyond astronomy to geology.
Kuiper had realized, even before I went to Yerkes, that by gosh, we really need to be doing geology too.
But the only degrees available to Kuiper's students came from the university's astronomy department.
The astronomy department, which was tiny in those days, was one guy, Carpenter. And he didn't like Kuiper, and he didn't like any of us who were with Kuiper. And I wanted to be able to take some geology courses for my degree, and he said, you can do all you want, but they're not going to count. You have to get a degree in astrophysics. And I said, well, I don't want a degree in astrophysics.
And so there was kind of a gulf between the Stewart Observatory and Lunar and Planetary Lab. That has gone away and melted away with the discovery of extrasolar planets and the formation of planetary systems.
The missing geology link would come from Flagstaff, Arizona, where Dr. Gene Shoemaker established a branch of the United States Geological Survey called astrogeology. Shoemaker's team was creating geological maps of the moon. Some were based on images from the Lunar and Planetary Lab's photographic atlases. Shoemaker came to the University of Arizona and enlisted the help of Dr. Spencer Titley, a geology professor.
Gene Shoemaker came down to the department, I believe 1962 or 63, and talked about his new branch of astrogeology. He asked if I'd like to become part of it. I said, sure.
Titley became a mentor to Kuiper's students. The seeds of a multidisciplinary approach to planetary science were being sown.
Spence Titley took us really under his wing, just voluntarily.
He said, look, I don't know what you guys need to take, but you're welcome to come over in geology and take whatever you think. You can take astronomy courses and geology courses, whatever mixture you want.
I took the three of them and retreaded them as geologists.
In the years to follow, planetary geology would become a critical component of how we study other worlds. In 1964, NASA sent a contingent of astronauts to Kitt Peak Observatory for a first-hand look at the moon. Spencer Titley became the future moonwalker's personal liaison during the visit. He recalls watching astronaut Ed White arrive in a fighter jet at Tucson's Davis-Monthan Air Force Base. White was dressed appropriately for the desert.
I remember Ed White climbed out of his F-102, reached in, grabbed a cowboy hat, put it on.
Just a year later, White became the first American to take a walk in space.
Okay, I'm separating from the spacecraft.
Okay, separate from the spacecraft at this time, all right.
Okay, my feet are out.
NASA was learning how to live and work in Earth orbit. But the moon remained a distant target, visible only through the telescope. It was time for a closer look. NASA's Jet Propulsion Laboratory in Pasadena, California, prepared 3 series of robotic spacecraft to visit the moon ahead of the astronauts: Ranger, Surveyor, and Lunar Orbiter. First up was the Ranger program. The plan was simple: equip the spacecraft with television cameras and crash land them into the moon, providing the first up-close look at the surface. The scientists behind Ranger included a who's who list of Southern Arizona lunar experts.
Dr. Shoemaker, Mr. Whitaker, and the principal experimenter, Dr. Kuiper.
But the program was beset with problems. Engine failures left Ranger 1 and 2 stranded in Earth orbit. Ranger 3 and 5 missed the moon entirely, and Ranger 4 lost guidance and smashed into the far side of the moon. The situation was becoming desperate.
Ranger 6 was going to work. I mean, if it didn't, heads were going to roll.
Ranger 6 was a perfect spacecraft launch, perfect separation of the boosters, perfect landing exactly where it was supposed to hit on the moon. Everything was perfect except the camera would not turn on.
No pictures, and so boy, people were unhappy.
So Ranger 7 then, it really put NASA's future on the line, the whole lunar program on the line.
I thought, okay, same old thing, let's do it again. So I made out the list, what the takeoff time should be from Canaveral, so that the camera on the Ranger could come down and get the best pictures. And I said, this one is best. And so that's the one they targeted it to.
Aiming point south of crater Copernicus.
5, 4, 3, 2, 1. Ignition main stage. This is Goldstone TV Control. Preliminary analysis of the video data indicates normal operation of cameras. We definitely have lunar data.
We were saying, we want to see those pictures.
10 seconds to impact. Video still good. Excellent signal strength. 3, 2, 1. Impact. Impact has occurred at 1325502. Impact has occurred. All video data was excellent right up to impact. All cameras were functioning.
The Polaroid prints were flown from Goldstone. To the experimenters in the Space Science Analysis Area.
This is a great day for science, and this is a great day for the United States. What has been achieved today is truly remarkable. We have made progress in resolution of lunar detail, not by a factor 10, nor by a factor 100, but by a factor of 1,000.
By a factor of 10, by a factor of 100, but by a factor of 1,000.
The thrill was to see the moon close up, closer as the spacecraft got closer to the impact site, and begin to see for the very first time the topography of the moon. And then at the very last, of course, the picture taken, 100 feet or so above the moon, showing this very smooth landscape with a few rocks protruding, but basically a very smooth, powdery type landscape. It's astonishing that it was only 5 years later that we landed there. Just unbelievable.
Following the Ranger program, the first of 5 Surveyor spacecraft soft-landed on the moon to analyze the lunar soil. Surveyor 1 landed in June 1966 and sent home panoramic photographs of the surface. But when scientists published the exact location of the spacecraft, Ewan Whittaker noticed a discrepancy.
The surveyor had scanned the horizon, and there were some white mountains sticking up on the horizon, and an article had been published, and they said from this triangulation we think Surveyor 1 has landed right here on the lunar surface. I did my analysis a little more carefully probably, so I said no, it's here, and wrote an article for Science magazine and put that in. And they decided, oh, I think he's right.
A year later, in 1967, NASA called upon Whittaker again to find Surveyor 3.
Oh, you're the guy who found Surveyor 1. You can find Surveyor 3, please. I got the orbiter pictures laid out, and the one little panorama, that first picture that the surveyor had put out, I was going around with a magnifying glass, 23 hours in all, till I found this one crater there. I said, hey, looks like this is it.
Whittaker's find would be an important piece of information just 2 years later, when a pair of astronauts would pay the spacecraft a personal visit. Meanwhile, NASA's lunar orbiter probes were circling the moon, photographing future astronaut landing sites in high resolution. Dale Shellhorn, a Boeing engineer working on the program, had a bold plan for the ultimate photo op, a picture of Earth taken from the moon. Shellhorn had earned his physics master's degree from the University of Arizona.
I knew we could point it at the Earth, of course. And yet that was absolutely forbidden because we're on an incentive contract and we get paid because we take good photos for the astronauts to land on the surface of the moon. We were the geeks in those days. We were the guys flying this beautiful hardware. So they especially thought, well, you can't trust these geeks.
It was a risky proposition. If Lunar Orbiter got stuck in the wrong orientation or was accidentally pointed at the sun, the entire mission could be lost, not to mention Shellhorn's job.
And I thought, well, let's get it as Earth is setting. In other words, we could be looking at the Earth, and then as we get behind the moon, it looks like the Earth sets. I said, well, as we go over that, let's just smear what we see of the moon in front of that so that there's some interest to this image.
4 days later, the photograph was received at one of NASA's Deep Space Network satellite dishes in Madrid, Spain.
The guys in Spain were all on the radio together. They said, my God, look, this is a great picture. It's really come out great.
It was the first time we had ever seen our planet from deep space. The iconic photo of a crescent Earth set the stage for a dramatic conclusion to the space race.
12, 11, 10, 9. Ignition sequence start. 6, 5, 4, 3, 2, 1, 0. All engine running. Liftoff. We have a liftoff. 32 minutes past the hour. Liftoff on Apollo 11.
It had been 8 years since John F. Kennedy declared that humans would walk on the moon by the end of the decade. Gerard Kuiper and the Lunar and Planetary Lab had helped pave the way by publishing groundbreaking lunar atlases and by participating in 3 robotic spacecraft programs. Now astronauts Neil Armstrong and Buzz Aldrin would make the first attempt to set foot on another world.
Eagle looking great, your go.
I was a member of the Lunar Operations Working Group. Our job for Apollo 11 is to find out exactly where they landed. When they came down to land, it was too rocky, that area, and they had to keep going, which made it a lot more difficult to find them.
4 forward, drift into the right a little. 6.5. 30 seconds forward.
When they landed, they only had a few seconds of fuel left. You know, if it had gone any further, they would have crash landed, but they did it. And so, I mean, it was really tight, you know. We kept saying, oh, God, they're going to make it, they're going to make it, they're going to make it.
Contact light. Okay, engine stop. We copy you down, Eagle. Houston, Tranquility Base here. The Eagle has landed.
And they sent back pictures from the ground, and we said, well, where the heck are they? And here's where they should be. And okay, there's a crater over there, and looking at the lunar orbiter picture, well, where's that crater? Well, there's thousands of craters. And it was driving us crazy. We did find it. We finally did it, but it took a long time.
It's one small step for man, one giant leap for mankind.
To watch that, to see those guys on the moon, wanting to be there myself, it was magical.
The first time a human had ever stepped on another planetary body. First time, 1969, July 20th. It was, well, you can imagine, it was incredible.
Apollo 11 was a success, but because the lunar module had missed its landing target by 4 miles, NASA wanted Apollo 12 to demonstrate a pinpoint landing. The space agency needed a known location on the lunar surface. 2 years earlier, Ewan Whittaker had given them one by finding the Surveyor 3 spacecraft.
And that's why they targeted Apollo 12 to that place because it was a known position. Ewan, thanks for your unique, essential work on the precise location of the Surveyor 3 spacecraft. It had made all the difference in the success of our pinpoint landing 19th November 1969. Our primary mission objective would have been a failure if we had not been so careful and caring. Alan Bean, Apollo 12. To Ewan, thanks, best wishes, Richard Gordon, Apollo 12.
Thanks to the efforts of scientists and engineers around the country, the moon had been transformed from a barren, unknown world to a neighborly destination. We mapped its features. We sent probes to its surface, and we walked on its soil. For the Lunar and Planetary Lab, the moon was only the beginning. Spacecraft have visited every planet in the solar system, turning distant points of light into beautiful, mysterious worlds. The University of Arizona was there for it all and continues to be at the forefront of planetary exploration. Gerard Kuiper remained the director of the Lunar and Planetary Lab for 13 years. He died in 1973. Years later, a band of icy objects at the edge of the solar system was christened the Kuiper Belt in his honor. In 2015, the New Horizons spacecraft will reach Pluto, which was classified as a planet until 2006. Pluto is one of the largest known Kuiper Belt objects. The exploration of our solar system continues. The scientists that worked with Gerard Kuiper at the dawn of the space age were part of a defining era that saw the birth of an entirely new field of study.
There was no planetary science at that day. In fact, I would say that Kuiper was probably the founder of planetary science.
So the Lunar and Planetary Lab in the 60s, was there at the beginning and there at the creation, and played a really important role in the days when the first planetary exploration was really getting started.
I think all of us at the Lunar and Planetary Lab realize how lucky we are to be living in this age, because you only discover these things once. So it's a very, very special time that can't happen again.